Hi guys, welcome to your Unit 5 Lesson 1 Notes on Slope. By the end of the day, you will be able to find the slope of a line given the coordinates of 2 points on the line. Now before we talk about slope, let's talk about stairs. Looking at these stairs, which set would you say is steeper? Well, when we compare steepness, we basically compare how fast it's rising. We have these stairs going up this way. We have these stairs going up. Come on. I'm going to make a straight line connecting all these points on the stairs like that. Okay, and if I were to compare those two stairs, then I would say, oh, hey, look, it looks like B is steeper. Why is B steeper? Because it rises higher over a shorter distance. So we say that the line goes higher over a shorter distance. Now, if we're not talking like we're in first grade, we say it goes higher, or we can say, instead of goes higher, we can say it rises over a shorter distance, over a shorter run. Okay, so we have rise over run. And you guys, that's our whole lesson. That's our whole lesson of the day. We have rise over run. Remember that? Love it. It's your key idea. To find the slope is to find rise over run. Cool, right? Now let's do some examples. So we say that the slope is a ratio of the rise or the vertical change. So rise is how far it goes up. It's change up or down to the run. In fact, I'm going to make this whole thing green. Slope is rise over run, which is the horizontal change. So to have it in a picture, the slope of a line is exactly how far it goes up over a certain distance across. So you can say that slope is rise over run. So you can have like how much does it go up versus how far right does it go. You can do like the change up over the change right is fine as well. You can do vertical change over horizontal change. So the slope of the slope of this line, how far does it go up? It goes up 1, 2, 3, 4. I'd say that's rise is 4 over 4 over. How far does it go over this way? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 over 10. So we go up 4, right 10. But that reduces 4/10 is the same thing as 2/5. So we say the slope is 2/5. However, we could have just done it this way. We could have gone, okay, that goes up 1, 2 over 1, 2, 3, 4, 5. There, giving you 2 over 5. Oh, hey, there's your slope. Your slope is 2/5. Cool. So again, your slope is rise over run. This is your key idea. Write it, love it, copy it, because you're going to want to use it throughout the whole lesson. Okay. Now that's nice, but a formula for a slope, the rise and run, it's nice to plug numbers in. So rise is your vertical change, right? It's the change in your y values over the change, not in your y values this time, but your change in x values So a nice formula that we use is we'll say, okay, if we have 2 points, if you have an x and a y, oh, but we have 2 of them. So you have, let's say, x1, y1, x2, y2. Then you first find the difference in your y values, and then you find the difference in your x values. So you'll say, okay, well, that's y2 minus y1 over x2 minus x1. So you find the change in your y values, and then you find the change in your x values. And that's it. That's your formula for slope. We say that slope is equal to m. We use the word m for, or not the word. We use the letter m for slope. If you really want to know why, you can ask me in class. So the short answer is no one knows, but we have some good guesses. Okay. All right. In real world problems, slope is also called the rate of change. So if you need to know how fast something changes, that's slope, or it's the steepness of a graph. I don't know if that's a real word or not, but there you go. Alrighty, so that's great. That's kind of a lot of theory. Let's put it into practice. First, I'm gonna paste my reservoir run, because that's the important part. Okay, so what do we notice about this graph? Well, we know that the x's go up by 3 every time. So the change in x is plus 3, and the change in y goes down 1 every time. So every time that x increases by a positive 3, y decreases by 1 unit, or you could say it increases by -1 because it's going to decrease. Okay, anyway. But on our graph, that looks like, okay, so we go down 1, we go over 3. And guess what? It's the same thing, so I can just do it again. Down 1, over 3, down 1, over 3. This is a change of -1 plus 3. So that's equal to, our rise is -1, our run is 3, so our slope is -1/3. 1/3. There's just one of them. Isn't that so fun? So good. Okay, great. So let's do, how about like 4, and then we'll call it. Okay, great. Oh, we don't have any points on our graph. But just kidding. There's an infinite amount of them. Where do we have some quality points? There's one here. There's one here. There's one here. Those are going to be our easiest points because we can tell exactly what they're at. So we can go with, what is this? -1.5 up 1.5. Go over 0 up 1, or over 1.5 up 0.5. So what we need to do is we need to figure out our vertical change over our horizontal change. So how far do we go down? Let's pick these 2 points. We'll go from 0, 1 to 1.5, 0.5. Okay, so we go down from 1 to 0.5. That is a change of -0.5. And our horizontal change, we go from 0 to 1.5, is a change of positive 1.5. So we say our slope equals our rise over run. We went down 0.5. Our run was 1.5. We get -0.5 over 1.5, which is 1/2. No, just kidding. Oh my goodness, guys, I didn't write this down. It's a third, yeah, which is -1/3. So that's our slope. Ta-da! Cool. All right. Now, let's do this one. Oof, we don't have a picture to go with it. but we don't need our picture. We've got our formula. So the formula for slope, remember, is still rise over run. It's just the change in y, how far the vertical changes, and the change in x. So we're going to label our points. Let's make this our point number 1. So that's our x1 and our y1. And this is our x2 and our y2. So we're first going to find the change in y's, and then we're going to find the change in x's. Okay, so y2 is 7, y1 is -2, x2 is -4, x1 is 3. Up on top, we see we have minus a negative, which means make them positive. 7 plus 2 is 9. -4 minus 3 is -7. Yuck. We're going to leave it as is. Yay, fraction. Okay, 2 more. Let's see what happens when we have these guys. All right, let's bring it down again. We need our rise over our run. Remember, our rise is our change in y's. So that's fun. So our rise here is going to be 5 minus 5. And then our run is our change in x's, giving us 8 minus 2. So we always want to find the difference between our x's and our y's. 5 minus 5, that's really nice. That's 0. 8 minus 2 is 6, but it doesn't really matter because that is just 0. Our slope is 0. We can say that line has no slope, or the slope is 0. Those are all valid statements. So that's exciting. Let's do another one. Here, the line through 3, -2, and 3, 6. Again, we want to find our rise over run. Our rise is our change in y's. So we'll do 6 minus -2. All over our rise is our change in x, which is 3 minus 3, means there's no change in x. So that'll be over 0. Remember that 6 minus -2 is the same thing as 6 plus 2, giving us 8 over 0. Guys, we're not allowed to do that. Whenever you have anything divided by 0, we call that undefined, because we don't have a definition for it. Undefined. Yeah, there we go. And that's it. So we just say the slope is undefined. Fun, huh? Okay, so there you have it. Our key idea of the day. Slope is rise over run, and the formula for that is the change in x underneath the change in y. It's really nice that rise rhymes with y's. So rise over run, y's over x's. We say slope is always m. That'll come in handy later. Okay? Yay! You're not done though. We have 4 pictures to help you. And just for funsies, let's do these pictures backwards. Haha. All right. So we had just talked about undefined. What does that mean for our graph? If we were to do an excellent, amazing, clearly a lot of time went into that graph, amazing, wow, great, and we were to plot these points, we go over 3 down 2. There you go. There's 3, -2. And then we went over 3 up 6. Over 3 up 6, like this. Then our line looks like that. We say all vertical lines have an undefined slope, right? So if you have slope that's undefined, it's going to take the picture of a graph that looks like this. You're going to have, your x-axis and your y-axis, but then your line itself is going to be vertical. It can be there, or it can be over here, or it can be there, or wherever. We say it's undefined. So when your slope is something like 8 over 0, we say that's undefined. Or maybe it's, 5 over 0, or negative 13,000 over 0. Anything over 0 is undefined. And here's my funky way to help you remember that. You literally write the word undefined, and that N right there matches the verticalness. So undefined vertical line has an undefined slope. So spoiler alert, we're going to get the same kind of thing happening on this other side. I'm going to want to copy this. Hold on. Beep. Beep. Okay, anyway. Undefined slope. We also saw 0 slope, and that's with a horizontal line. So if you have your slope equals 0, you're going to have a horizontal line, and the fun way to remember that is you say 0, you've got that like horizontal-ish thing, 0. Okay, so that's fun. This makes sense if we were to graph this guy. We would have our amazing graph right here. Isn't that great? Fantastic. Okay, then we go over 2, up 5. 1, 2, 1, 2, 3, 4, 5. And then 8, 5. 1, 2, 3, 4, 5, 6, 7, 8. 5. Oh, hey, check that out. That's a horizontal line. So when you have 0 slope, it's going to be a horizontal line because there's no change in the rise. There's no rise. So there you go. So we have 0, we have undefined, and those are rare. You often won't see them. What you will see is you'll see a line that looks like this, and you'll see lines that look like that. When you have a line that goes up like this, we say that has positive slope. And when you have a line that goes down like that, we say that has negative slope. So here m is going to be greater than 0. Here m is less than 0. When it's 0, m equals 0. And if it's none of those, well, then we don't know what it is, so it's undefined. So there you go. 4 types of slope. And slope is how high it goes and how long it takes to get there. It's rise over run, change in y's, change in x. And slope is, so good. Okay, well, I hope you have a wonderful time on your homework.